Okay, let it die. Christian, give it up.
Hey guys, so my today's talk is called Let It Die. It's about long-running processes in Node.js. I think everyone who works with Node.js has long-running processes. Every web server, every daemon should probably run longer than just a Apache thread. So there are a few common problems with long-running processes. First of all, it's memory consumption. If you write really bad code, then your memory rises, and at some point it breaks, and you don't know why, which kind of sucks sometimes. Then DB connections can die. So in a threaded model, you have like a reset after each thread, after each request in a web server. And in Node, it's just you have to handle dead connections. You have to do reconnections. And then there's a problem if the code is not too good. It's probably that you walk into dead ends. If it's just there's a state, the application doesn't go on. And you don't know why, it doesn't log anymore, but the process doesn't die. And you have handled server shutdowns like with every thing else. So unfortunately, there is no good solution to this. There's not just installing a tool and our world is great. It's a long way to have a good and robust application. Basically, there are three things to do. First of all, it's the application design. You have to design your application that it's allowed to fail. So just when you start writing your application, think about the failures. Then think about your data structures. There, one point is like replication. If it's possible, keep it as simple as possible. If you've got simple data, it's easier to handle, it's easier to understand, and there will be less failures. And one of the most important things, if something goes wrong, you will probably know that something got wrong. And so you should have a good logging and monitoring. First of all, the application design. I will do this on a quick example. It's just a really simple daemon which takes a URL from one Redis list, processes it, fetches it, looks at the status code and puts it back into another Redis list. So it's really, really simple. Can everyone see? It's a bit small. So as you see, it's like we create a Redis client here. We've got two queues. One is called in and one is called out. And our queue does like it preserves a job, so it takes a job out of Redis. It's this part. It's like processing the job. It does something like here. We make a request. With the job, with the actual value of the job, and append to the processed job the status code and put it back. And the putting back does the job done. It starts it back to the other queue and says, okay, it's ready for the next. And I know with Node.js we can do it in parallel, but this example is not in parallel. It's just easier to show. Whenever our daemon runs, I can show you. Probably, I hope. Is it too small? It is. Okay, so what went wrong? As you see, we are on the very first step. There is no error handling, there's nothing. We will come to this. I will start my Redis server. It should be somewhere. Okay. And whenever we start now, okay, it says the queue is drained. There's nothing in there now. I will seed it. I've got just a very basic seed. hope I can find it. Yeah. Okay, now it got a really quick set of seeds and it's processing it now. It will take quite long because it's taking my mobile tethering, but it works. And if we look now, it's still very small. Can everyone see? Our out queue has like 2 entries now, and if we do pop out, we see we got on MNUG.com we got a 200, and yeah, there's nothing more in it. So now we've got a simple daemon, but it doesn't know anything. It just does what it should do, but there's no error case, there's no monitoring, it just dies. Whenever something goes wrong, it will die. First of all, with this queue daemon, we need some kind of recovery. Whenever it dies and it's in between processing a job, then the job is gone, and we don't like to lose any jobs. Maybe they're important, like sometimes data is important, so we won't lose it. What we do for recovery in Redis, for example, there's a rpop-lpush command, which is quite useful. It does exactly that. It takes it from the in queue, gives it to the daemon, and it's an atomic. It's just one single command, and it puts it at L puts it into another queue. It's called recover here. That's quite useful, or it should be when we work with real queues. It's really important to have an atomic command, because whenever we take it out, there's no chance to recover when it's gone. So it should be one command which takes it out and puts it to another queue, and Redis does this for us. When we work, like for example with Mongo or anything, we would just mark it as processing, so there is nothing deleted until it's finished. So our second one, it has the recover built in. You can see here we are using the rpop-lpush command, and it just takes it from the in queue and puts it to the recover queue. And the only thing which is different is in the job done, we first push the result to the out queue, and then we delete the first one from the recover queue. That's all we have to do. And whenever we shut down this process in between the processing, it will recover on startup. And the recovery itself is done here. When we call the preserver, it looks if there's no recovery. Okay, so there's the recover part. We look if anything is in our recover queue, and if there is something in, we queue it back to the in queue, and it's queued back on the very end of the in queue. So when everything is done, it tries it again, and it will do it again and again and again, which is not too good, because if it's the job which fails, if the data is bad of the job, we shouldn't try it again and again. So we can implement stuff like timeouts, like try it 10 times and decrement it in each try, but it's not there. It's just, if you like to do so, if you do it in a production way, you should probably add timeouts. Okay, so what about controlled shutdowns and kills? So if we start our process with upstart or anything else, or if the server is shut down for maintenance, then it sends a sick term to our process. And it's the same with it. If we are in the middle of a processing, we don't like to need to recover, because if it's a planned shutdown, normally everything is almost okay if it's just for maintenance, and we can wait until the process finished a job and then shut down. And the same with SIGINT. If we hit Control C, we don't like to just stop right in the middle of a job. We like to wait until it's done and then stop the process. So it's that part here. We just listen in Node. You can listen for the signals, and we listen for SIGINT and SIGTERM. So SIGINT and SIGTERM are the both signals who can be catched by the application and handled by the application. To handle a SIG-kill is, let's say, it's not allowed because there should be a way to kill your application. And if it's in a state where it doesn't stop anymore and it's just you can't finish or can't kill the process if you handle a SIG-kill here and don't let it die. So we just handle these rows. And if we try it again here, another seed. Okay, we run it. It's processing now, and I have to shut down Redis because if I just kill it, everything is gone. There's no persistence configured. Okay, the Redis connection is gone. Everything has failed. And if I restart the Redis server, it probably should not recover. Okay, recovered. That's not cool. Oh, right, you're right. I'm sorry. Yeah, I just forgot it. Now I sent the SIGINT and it said, thank you. Yeah, I think you know my talk better than me.
The next slide.
Oh, really? You will get a beer if you guess it. Okay, so if I bring it back now, yeah, it takes quite long to end the process because it's on mobile internet, so I hope it won't take forever. Okay, there's still no error handling. It timeouted because of the mobile. I will just try it again. Maybe I'll explain the difference. So what do we do here? We just say, okay, we like to stop, and it sets a flag, and whenever it's on a defined point where it can stop, it calls the callback, and then it exits the program with exit code null because it's a planned exit, so there is no error.
Is this abstracted that it works on different platforms as well?
No,
I work on Windows.
No, probably. I'm quite sure that there are like paths which are not like used to the path join in the logging on the next slide, which won't work on Windows.
Yeah,
but
no, the signals probably don't work.
Yeah, so I didn't.
I think some signals work because it simulates how you do thread dumps in Java, and that part works on
Yeah, but
Windows
that
for
works differently in the operating system than signals in Windows.
Yeah, so it's no cross-platform application. You probably shouldn't use it anyway for production. Yeah, I don't know. Yeah, it's still not doing something. I'm sorry. We'll just go on. So what's the next slide?
It's probably about
monitoring. Error handling.
About monitoring,
hopefully
actually.
about error handling.
Error handling? Oh no, it's about logging. So I think logging is one of the most important parts because whenever something goes wrong, you like to know that something got wrong, and you like to know what goes wrong because you can't fix it if you don't know what goes wrong. So logging has to be really robust, and you don't like to lose logs in any error case. So if you think about unhandled exceptions, you like to have a way to log that too. So your logging shouldn't die with an unhandled exception. There should be always any fallback in your logging which outputs something somewhere, and you can catch it and show what got wrong. So there are a few ways. There's first the console log. It's quite stupid. It just logs it to standard out. There's nothing really about it. You can't handle the levels or anything. Then you can use like a custom logger. In the next code example, I used just a custom logger. What I really like is, for example, to switch between standard error and standard out. So all emergencies I usually use, like for the bad things, if database connections die, I use the emergency level, and the emergency level lets the application die. So after an emergency, I like the initial state and get it back like the right way, the application, and it retries rebooting the application until it works. But for everything else, it goes to standard out, and usually the standard out is logged to Mongo or anywhere else, but the standard error it should be like to a file fallback. It should be a way like to the process output streams. Logging there is like a real fallback way. It works always. It should always work, even if an unhandled exception case. And there's, for example, Winston, which is a pretty good logging library for Node. There are all transports you can think about. There's a write transport, like I saw this afternoon. Yeah, it works. But I still like to use for exception cases like the standard out and catch it from outside the process to not lose any log. So my logging it's not called log, it's more called health, because it does a bit more than just logging. So it's just a basic example of handling levels and everything. You would normally use Winston for that. It's just for a showcase. And there you see on emerge, for example, I just log to standard error and exit the application. That's why you should do the recover, because your application should be allowed to die on each point of the application. Because when something goes wrong, you never like to be in a state where data is broken or corrupt. So it's okay in an emergency if just a process got shut down. There's alive. So it's for if you have a state in your application which is not defined and it doesn't go on in the daemon, for example. If I don't call a callback and it's just running but it's doing nothing, I usually don't know that's in that state, and that's like the alive log, which just does a touch on a file and it's get monitored from outside, and if there is no touch for 2 minutes, it will kill the application and restart it. Okay, data structures, just very short. You can't say that much about data structures, but because data structures depend on your application, so everyone has other data structures, and you can't just say make them easy. But if you've got like really complex data, it's complex. You can not change it the way you like. You can try to design it very intelligent, or use like databases which forces you to design them in a good way. But it always depends on the data. So keep them as simple as possible. Think about transactions. If the process breaks in the middle of a processing, you should have a possibility to roll back to maintain a proper state of your data. And it's not always possible. If you think about MongoDB, there's this two-part commit thing, which is kind of complex and it's not really fun to implement. So probably you go to a database which can do rollbacks and stuff like that if you're in a model like that. Now it's monitoring and demonization. For monitoring, I usually use, for demonization actually, Upstart. I think I don't have to say that much about Upstarts. It provides just a simple set of commands like starting and stopping and redirecting the outputs of the output streams to files. Simple upstart conf, I won't say that much about it. You can find it everywhere. There are thousands of examples for Node upstart confs. The next tool, which is really, really useful, is Monit. I don't know, did everyone work with Monit? So Monit is it. You can monitor everything. You can monitor your database. You can monitor the presence of or the state of a HTTP endpoint. You can monitor really everything, and that's the nice thing about Monit. It doesn't take care of the process, like for example forever. Forever is not really a monitoring, it's just handling your process for demonization, but a lot of people start forever with Upstart, and forever starts your node process, but there's no, you still need some monitoring, and why not handle the process, why not let Monit handle the node process? So, there are a lot of cases where forever dies, and I don't need forever if it dies. So I don't need that part. So it's just one more thing in the chain which can fail. So what do we monitor with Monit? First of all, we monitor the node process itself. Is it up? Is it down? How long is it up? What's really important is memory usage. The process uptime and the process health. The process health, I mean, it's the alive feature of the logging before. Is it still doing anything, or is it just running and not dying and doing nothing? First of all, in Monit, you have config files. That's the part of the node process. You just look at the PID file, and if something changes, probably restart. CPU and memory. So if you're interested in Monit, look at the Monit documentation. There's a whole set of stuff like total memory bigger than 2%, 10%, let it restart, let it alert. So you can define email templates which get sent to the administrator. You shouldn't do probably like over 1% every 1 cycles and let it send an alert to the admin. He won't be that happy. But it's really good if something really gets wrong in your application and it consumes like a huge load of memory. You can do it with like total system memory. The total memory is just the process memory. But you can monitor the whole system memory. You can monitor disk space. Yeah, everything. The next thing is the process uptime. So in applications, we really like the initial state because we know the initial state, it's defined and everything is good in the initial state, and it gets worse the longer the application is running. So if you design the application and it's designed to die in a good way, why not just killing it every 24 hours to have the initial state and to don't have problem with memory leaks and all this stuff. I won't say that you don't look at memory leaks. It's important to look at this stuff, but it makes it safer and it keeps like a lot of problems away. But you still should like log memory leaks and look for memory leaks. It's not like just do that and write bad code. The process health it's like the thing I told you before. It's like the Node alive log where the touch gets on every few seconds. And what's the really important thing about that is, so we are handling the SIG term and the SIGINT signals in our application. So, but if our application is a state where it does nothing, then we are not sure if it can handle these signals. So, and we are pretty sure that it won't get to the point where it says, okay, I'm ready to die now, and stops itself. So what's really important on this point is to send a SIG kill to really, really shut it down, no matter what it likes to do. Okay, so what's now really the clue of it? It's like, first of all, write good code. Like I said, it's not about writing bad code and monitor it. Write tests and run tests and get to know your application. You should know how much memory it uses in a normal environment, under normal load, because you have to set these borders in the monitoring, and they should be like you like to know if something goes wrong, and if you don't know how much memory or CPU your application consumes during normal processing, then you can't set these borders, and you will never find memory leaks if you don't know how much memory your applications consumes in a normal way. So monitor it, see if it rises. There's a small tool. It's called Node memtest. It's a really small tool. You can add a callback handler which listens for a leak. So you shouldn't use it in production, but maybe on staging, and it monitors your heap, and if your heap rises for 5 cycles, then it just throws the leak event, and you can log it and look at it, what happened. There's a heap dump in it, and just look at it. Just get to know it. Just know which classes use much memory. So basically, I really like the initial state. For me, initial state is the best state because I know what's going on there, and so let it die as often as possible in a controlled way. I've got an example in a virtual box. I'm not sure if it runs without internet. Probably not. It will do the same like before. I will add this talk on GitHub. I will give the link to Christoph, and there's a small Vagrant Ansible box included. You can start, you can play around. There's a monet setup with this daemon installed. You can play around with it, just get curious. Okay, a few resources, you can check them out. And that's all. Thanks for listening.